Okay, we are today going to be looking at section 13.3, finding probabilities using combinations. Now, these are different from permutations. Permutations is what we looked at last time. The difference is this time, a combination is a selection of objects in which order is not important. That's the key understanding here. So let's imagine a situation. Let's say that we've got, we'll start off with a simple one, the same as before. We'll look at letters of the alphabet. And let's say we've got the letters A, B, C, and D. And we want to know how many combinations of two letters there are in this list of letters. Combinations of two letters. Now we can write out the list. Let's try that, shall we? We'll start with the A's. So there's A, B, there's A, C, A, D. We can then start with B. So we've got B, A, B, C, and B, D. Start with C, C, A, C, B, and C, D. And then finish off with the D, A, D, B, D, C. Now, remembering what combinations are where the order is not important. So what we're going to do is we're going to identify any duplicates we have and cross one of them out. So we've got AB here and BA here. That's BA and AB is the same if the order is not important. The same thing, we've got an AC and a CA, an AD and a DA. We don't take any of those into account. Looking at BC, we have a CB. Okay, we've already seen that. Then looking at BD, we've got a DB. CD, we have a DC. So the total number of combinations that we can make with two letters is the combinations. Total number of combinations is, in this case, 1, 2, 3, 4, 5, 6. Okay? Far fewer than the number of permutations. What we wrote down originally was the permutations, and we crossed out the duplicates. So there we go. There are the total number of combinations. And as before, it becomes tedious to write all of these out every time we do a problem. We have a formula to calculate this, and our formula is this. The letter for combination is C, so we have NCR, and the formula is this. N factorial divided by N minus R factorial, just the same as permutations, but then multiplying by R factorial there. Okay? So let's look at an example. So let's say we'll do exactly the same thing. So the number of combinations of 4 objects taken 2 at a time, which is exactly what the calculation we've done above here. Our total number of objects, so this would be, we're choosing 2 from 4, so that would become 4 factorial over 4 minus 2 factorial times 2 factorial, and when we work that out, we get the answer. So it's 4 factorial over 2 factorial times 2 factorial, which equals, if you try that in your calculator, that equals 6. Let's look at a specific example. We have this situation. You order a sandwich at a restaurant, and you can choose 2 side dishes from a list of 8. How many combinations of side dishes are possible? Well, order is clearly not important in this case, so this is a combinations problem. So our combination is there. We have a total number of 8 choices, and we are going to take 2 of those. So that, going back to our formula, which is n factorial over n minus r factorial times r factorial, becomes 8 factorial over 8 minus 2 factorial times 2 factorial. Let's simplify that. 8 factorial over 6 factorial times 2 factorial and we calculate that, we get 28. Okay, so there are 28 possible combinations of 2 side dishes chosen from a list of 6. All right. Okay, so let's look at the examples we're going to do. We're going to be working on page 858. And we're going to start off with the simple problems. We're going to do questions 6 through 13, which I shall give you below. And there they are. Okay, one of the key things that we need to understand when we are looking at permutations and combinations is when to use permutations and when to use combinations. So the key thing is this: permutations, order is important; combinations, order is not important. Okay? Right, okay, so the problems I want you to look at now are questions 16 through 19. I'm going to do these slightly differently. What we'll do is I'll leave them here for you to work through, and in a couple of minutes I'll go through each individual problem and discuss why each one is the way they are. So let me put these in here now. Okay, so here are the problems. Please pause the recording now, and we will answer the questions, and then I will go through each one and explain each one in turn. Okay, right. Let's look at the first one, question 16. 4 students from your class of 120 will be selected to organise a fundraiser. How many groups of 4 students are possible? Key question: is order important? Now, when you're thinking about this, is there a rank of the students? Is there a president and a secretary and a vice president and a treasurer, which, there might be in a student council, in which case, the individual positions are important, or is this just a random group of 4 people? I think this is a random group of 4 people. It just says 4 students, how many groups of 4 students, and there is no indication that order is important. So in this case, we are looking at a combination. So calculate this based on that. Question 17. 10 students are auditioning for 3 different roles in a play. In how many ways can the 3 roles be filled? Well, the key word here is different. now, there could be, I don't know, whatever play it was, there's a king, a queen, and a murderer, or something like that. Each of those roles is a different role. So in this case, clearly, the order, the position you choose, or the role you're given, is an important thing. So here, this is clearly permutations. Order is important. 18, to complete an exam, you must answer 8 questions from a list of 10. In how many ways can you complete the exam? Now, here, is order important? Yes or no? Well, I think the answer is no. It doesn't matter which question you complete first. It's just a random sample of 8 questions. So I think here we're going to say order is not important, so combination. And lastly, in how many ways can 5 people sit in a car that holds 5 passengers? This is slightly less obvious, but I think this is also not too difficult if you think about the situation. Let's quickly draw a sketch. You've got 5 passengers in a car. Presumably there's a driver and a front seat and then 3 in the back. Each of those positions is a different place. I mean, the driver, for example, that's an important position. There's 5 different ways that you could have a driver, and then the front seat and everything else. So I think here the order is important, or the position that people sit in the car is significant. It's certainly different. So I think here this is also a permutation. Once you've decided those 4 things, go on and complete the problem, answering the questions as you see fit. Okay, so what I think we're going to do is we're going to look at how we can use combinations to calculate probabilities. Now, we've got a situation here. The yearbook editor selected 14 photographs, including one of you and one of your friend, etc. You can read it yourselves. Now, there's room for 2 photos at the top of the page. What's the probability that your photo and your friend's photo are the 2 placed at the top of the page? The key thing here is working out what the probabilities of the events are. So let's remind ourselves what probability is. So there's the probability calculation. The theoretical probability is the number of favourable outcomes divided by the total number of outcomes. The number of favourable outcomes, the total number of outcomes, let's look at that bit first. So the total number of outcomes here. Now this is a combination. The point about this is the order of the pictures is not important. The photos are placed at random. There's room for 2 photos at the top of the page. It doesn't matter which one's first, you and your friend or your friend and you. So we're looking at a combination, and let's do our combination calculation. So there's a total number of 14 photographs, and we're choosing 2, so there's our combinations. So that's 14 factorial divided by 14 minus 2 factorial times 2 factorial, and that calculates, we do that in a calculator and we get the answer 91. So the total number of outcomes is 91. Now, the number of favourable outcomes. Well, really, there's only one. It's just you and your friend at the top of the page. Your friend and you, it's the same thing, because combinations, the order is not important. So the number of favourable outcomes is 1, total number is 91, and therefore the probability is 1 over 91. Okay, so the theoretical probability equals 1 over 91. All right? So what I'd like you to do is to work on the problems on page 859. There are problems there 23 through 26, so I'm going to include them below. Okay, there's question 23. All right, let's move on to the next one. Question 24. And 26. Fantastic. Okay, so complete these, do the homework, and then moving on to the next topic.